Hello dear students, welcome to ECE Academy Benefactor. In this class we will be seeing design of an ideal high pass filter with a frequency response given. The topic is from the design of FIR filter. The desired frequency response HD of e to j omega is given as 1 for pi by 4 less than equal to mod omega less than equal to pi, and is equal to 0 for mod omega less than equal to pi by 4. So, the desired frequency response of an ideal high pass filter is given to us, and we are required to find the value of h of n for capital N is equal to 11, and also find h of z using Hammingwindow. In the previous video we have designed using Hammingwindow. In this video we will be designing FIR filter using Hammingwindow. Okay, let us start the solution. So, as you know, the design steps of FIR filter, HD of e to j omega, that is the desired frequency response, is given in the problem. Based on this, we have to find the filter coefficients HD of n. It is also known as impulse response of the filter, HD of n. It is of infinite in nature because n is varying between minus infinity to infinity. First compute HD of n, and then we need to find what is a Hamming window, which is symbolically represented as WH of n. WH of n is for Hammingwindow, this is for Hammingwindow, and WHN of n is for Hammingwindow. So, as we are doing for Hammingwindow, we will find WH of n coefficients. Okay. Then we will find h of n, that is the truncated impulse response or the finite filter coefficients. After finding h of n, we will apply the z transform and find the transfer function of the filter h of z. This h of z is containing positive powers of z, so it is not physically realizable. So, we need to find the transfer function of a physically realizable filter. So, we are finding h dash of z. Okay, so these are the steps: HD of n, WH of n, h of n, h of z, h dash of z. So, first step, we have written the desired frequency response HD of e to j omega as given in the question. Based on this definition, the frequency response of ideal high pass filter is drawn here. It is telling that its value is equal to 1 between the range pi by 4 to pi. Between pi by 4 to pi, its value is 1. As it is a mod, between minus pi to minus pi by 4, its value is 1. So, in these two ranges, the value of HD of e to j omega is 1. In between minus pi by 4 to pi by 4, mod omega less than equal to pi by 4, its value is 0. So, it is 0 here. Okay. So, based on the definition, we can draw the frequency response of the graph of an ideal high pass filter. Next step is to find HD of n. HD of n is given by the formula 1 by 2 pi integral minus pi to pi HD of e to j omega e to the power j omega and d omega, which is written as, this integral limit is from minus pi to pi by 4 and pi by 4 to pi. So, we have split this integral into two parts. One is from minus pi to minus pi by 4, other integral is from pi by 4 to pi. Minus pi to minus pi by 4 HD of e to j omega dot e to the j omega n, and in this range its value is 1. HD of e to j omega value is 1, plus integral pi by 4 to pi HD of e to j omega, its value is 1, e to the power j omega and d omega, and we know that the integral of e to j omega and d omega we are integrating this term with respect to omega. So, it will be coming as e to the power j omega n by jn. That is written here, integral e to the power j omega n by jn. The limits are from minus pi to minus pi by 4 plus e to the power j omega n by jn, integral pi by 4 to pi, and then substituted the upper limit and the lower limit, and we have rearranged the denominator part, taken pi n outside and 2 inside. So, it is now becoming 2j. Okay. So, on writing e to the power, substitute omega value is minus pi by 4, e to the power minus j pi by 4 and minus e to the power of omega value is minus pi, e to the power minus j pi n by 2j plus e to the power j omega, e to the power j omega is pi, e to j pi n minus e to the power of j pi by 4 of n by 2j. So, 1 by pi n. On rearranging the terms, we can collect pi n terms together. We have written it as e to the power j pi n minus e to the power minus j pi n by 2j minus of, this minus is taken outside, e to the power j pi by 4 n minus e to the power of minus j pi by 4 of n by 2j. If you look at this formula, it is resembling as this one, that is e to the power j theta minus e to the minus j theta by 2j is written as sin theta. Here this theta value is how much here? E to the power j theta minus e to the minus j theta. So, theta is pi n by 2j, e to the j theta minus e to minus j theta by 2j is sin theta. Theta is how much? Pi n. So, it is written as sin pi n minus, what is pi here? What is theta here? Pi by 4 of n. So, it is written as sin of pi by 4 of n. So, HD of n is coming to be as 1 by pi n sin of pi n minus sin pi by 4 of n. So, we have computed HD of n. Next step is to find what is HD of 0, HD of 1, which is HD of 2, HD of 3, HD of 4, HD of 5. We need to find from HD of 0 to HD of 5 because this small is n is varying between minus of n minus 1 by 2 to capital N minus 1 by 2, and capital N value is 11, 11 minus 1 by 2 is minus 5, minus 5 to 5. So, we will see how to find HD of 0 now. HD of n is coming to be as sin pi n minus sin pi by 4 n by n pi. So, let us find HD of 0. If we directly put n is equal to 0 in this limit, as n is 0, it becomes infinite. So, it is not correct. So, when we make limit n tending to 0 for finding HD of 0. HD of 0 is equal to limit n tending to 0 sin pi n minus sin pi by 4 n by n pi. On this solving, we will get it as 0.75. If you know in detail how to solve this equation, I have done in my previous video class. Okay, so HD of 0 is coming to be as 0.75. HD of 1 is equal to HD of minus 1 because of symmetrical impulse response is coming to be as, now substitute n value as 1 in this equation, sin pi minus sin pi by 4 by pi. We are getting it minus 0.225. Next step, HD of minus 2 is equal to HD of 2. Now substitute n value as 2 in this above equation. So, it becomes sin 2 pi minus sin of pi by 2 by 2 pi. So, it will be equal to minus 0.159. Next find HD of minus 3 is equal to HD of 3. Substitute n is equal to 3. Sin 3 pi minus sin 3 pi by 4 by 3 pi, which is coming to be as minus 0.075. HD of minus 4 is equal to HD of 4. Substitute n is equal to 4. Sin 4 pi minus sin pi by 4 pi is equal to 0. Next step, HD of minus 5 is equal to HD of 5, which is coming to be as sin 5 pi minus sin 5 pi by 4 by 5 pi. On simplifying, we will get the value to be as 0.045. Next step is to write the definition of Hamming window. Hamming window is symbolically represented by WH of n, which is given by 0.54 plus 0.46 cos 2 pi n by capital N minus 1 for minus of n minus 1 by 2, which less than equal to small n less than equal to n minus 1 by 2. In this range, WH of n equation value is this much and is 0 otherwise. So, the value of capital N is given to be as 11, capital N is 11. So, this range becomes 11 minus 1, 10, 10 by 2 is 5. So, it becomes, the range becomes minus 5 to 5. So, the definition of WH of n, that is a Hamming window definition for the given question is 0.54 plus 0.46 cos of, substituting here capital N value is 11. On simplifying, we will get cos pi n by 5. For minus 5 to 5, this is the equation and is 0 otherwise. Next step is to find what are the values of WH of 0, WH of 1, 2, 3, 4, 5. Okay. So, we know WH of n is equal to WH of minus n because of symmetrical response. WH of n is equal to WH of minus n. So, we can write WH of 1 is equal to WH of minus 1, WH of 2 is equal to WH of minus 2, WH of 3 is equal to WH of minus 3, WH of 4 is equal to WH of minus 4, WH of 5 is equal to WH of minus 5. Okay. So, when you are finding WH of 0, that means substitute n value as 0 in this question, in this equation. Okay. On substituting n as 0, we will get it as 0.54 plus 0.46 coming to be as 1. Next, we are finding WH of 1. So, put n value here as 1. 0.54 plus 0.46 cos of pi by 5 coming to be as 0.912. Now, for n is equal to 2, substitute n is equal to 2 here. WH of 2 is coming to be as 0.54 plus 0.46 cos of 2 pi by 5 equal to 0.682. WH of 3, by substituting n is equal to 3, we get it as 0.54 plus 0.46 cos of 3 pi by 5 coming to be as 0.398. WH of 4 is equal to 0.54 plus 0.46 cos of 4 pi by 5 equal to 0.1678. WH of 5 is equal to 0.54 plus 0.46 cos of pi. Substituting n is equal to 5, we get this equation, and on simplifying the values coming to be as 0.08. So, after finding WH of 0 to 5, what we have done till now? We have computed HD of n. For what values? From HD of 0 till HD of 5. Next, we computed WH of n, the Hamming window coefficients from WH of 0 till WH of 5. So, these are the two steps we have completed now. Next step is, so this HD of n is of infinite in nature because here n is varying from minus infinity to infinity, and this Hamming window is a finite sequence because its range is varying only between -5 to 5. It's an HD of n is infinite and WH of n is finite. Next step is to find H of n, which is known as the filter coefficients using Hammingwindow sequence. The equation for H of n is equal to HD of n dot WH of n for -5 to 5, -5 less than equal to small n less than equal to 5 and is 0 otherwise. So, next we have to find H of 0 till H of 5. As we know HD of 0, WH of 0, we can easily compute this one. Here also H of n is equal to H of minus n because of symmetrical nature. H of 0 is equal to HD of 0 dot WH of 0, which is coming to as 1 dot 0.75 equal to 0.75. H of 1, which is equal to H of minus 1, is equal to HD of 1 dot WH of 1, which is coming to is minus 0.2052. H of 2 is equal to H of minus 2, which is equal to HD of 2 dot WH of 2, is coming to be is minus of 0.1084. H of 3 is equal to H of minus 3 is equal to HD of 3 dot WH of 3, coming to be as minus 0.03. H of 4 is equal to H of minus 4 equal to HD of 4 dot WH of 4 is coming to be as 0. So, H of 4 is coming to be as 0. H of 5 is equal to H of minus 5 is equal to HD of 5 dot WH of 5, which is coming to be as 0.0036. So, we have computed the filter coefficients using Hammingwindow. Next, we will find the transfer function H. The transfer function of the filter is H of z, given by the equation H of 0 plus summation small n is equal to 1 to capital N minus 1 by 2 H of n z to the power of n plus z to the power of minus n. H of 0 value we got it as 0.75. Capital N value is 11. 11 minus 1 by 2. 10 by 2 is 5. So, 0.75 plus summation small n varying from 1 to 5 H of n z to the power of n plus z to the power of minus n. Expand the series. First put n is equal to 1 and then 2 and then 3, 4 and 5. I have expanded the series. 0.75 plus H of 1 z to the power 1 plus z to the power minus 1 plus H of 2 z to the power 2 plus z to the minus 2 plus H of 3 z to the power 3 plus z to the power minus 3 plus H of 4 z to the power 4 plus z to the minus 4 plus H of 5 z to the power 5 plus z to the power minus 5. Now we are having H of 1 value, H of 2 value, H of 3 value, H of 4 and 5. H of 4 we got it as 0. So, H of 1 value is how much? Minus 0.2052. H of 2 value is minus H of 2 value is minus 0.1084. H of 3 value is minus 0.03. H of 5 value is 0.0036. Okay. So, if you look at this transfer function H of z, it is containing positive powers of z. So, it is not physically realizable. Next step, the final step is the transfer function of the realizable filter, which is denoted by H dash of z. H dash of z is equal to z to the power of minus of n minus 1 by 2 dot H of z. Capital N value is 11. So, it will become H dash of z is equal to z to the power minus 5 dot H of z. We got H of z here. Multiply this complete equation with z to the power minus 5. So, on multiplying this complete equation with z to the power minus 5, we are getting H dash of z as 0.0036 minus 0.03 z to the power minus 2 minus 0.1084 z to the power minus 3 minus 0.2052 z to the power minus 4 plus 0.75 z to the power minus 5 minus 0.2052 z to the power minus 6 minus 0.1084 z to the power minus 7 minus 0.03 z to the minus 8 plus 0.0036 z to the power minus 10. So, we get h dash of z and it is physically realizable filter transfer function. Okay, so we obtained the transfer function of the realizable filter using Hamming window. So, what we have done now, hd of e to the power j omega is given, that is the desired frequency response is given. First we computed hd of n by the help of the formula 1 by 2 pi integral minus pi to pi hd of e to the power j omega e to the power j omega and d omega, and then written the Hamming function, Hamming window definition wh of n as 0.54 plus 0.46 cos of 2 pi n by n minus 1, and then this is an infinite nature, this filter coefficients which is ranging between, and this is a finite ranging between minus 5 to 5. So, based on this we have computed h of n. H of n is coming to be as hd of n dot wh of n, and then based on this h of n we computed h of z transfer function, and then computed h dash of z which is equal to z to the power of minus of n minus 1 by 2 dot h of z. Okay, these are the steps and the solution of the problem using Hamming window. I hope you have understood the class. If you have any queries, you can post in the comment section. Thank you students. Good luck.